SDI-12 is a standard that allows multiple sensors to be used on a data logger channel. In this video, I will demonstrate how 3 common sensors can be used on one channel of a Campbell Scientific data logger. The equipment I will use is a CR1000XE data logger, a HygroVue 10 temperature and relative humidity sensor, a BaroVue 10 barometer, and a RainVue 20 rain gauge. I need a 12-volt power supply such as the PS200. To securely connect multiple wires to a single channel, I will use an SDI-12 DIN rail terminal bus kit. SDI-12 sensors ship with a default address of 0. To allow multiple sensors on the same channel, each sensor must be assigned a unique address. To avoid confusion when adding or replacing sensors, it is good practice to avoid using address 0. For this video, I will be using the following addresses: HygroVue 10, address 1, BaroVue 10, address 2, RainVue 20, address 3. The CR1000XE has an SDI-12 terminal mode that I will use to change sensor addresses. But before terminal mode can be used to send SDI-12 commands, I must first configure the control port I will use for SDI-12. This is done by running a program that uses the SDI-12 recorder instruction. I will use the shortcut program generator as a quick way to create that program. First, I will add the HygroVue 10 from the sensor list. It is important to select my desired sensor address, in this case 1, in the dialog box. The wiring tab in shortcut also allows me to select which C port is used on the data logger. Click OK to finish adding the sensor. Now I will add the BaroVue 10 with address set to 2. Lastly, I will add the RainVue 20 with address set to 3. The RainVue requires setting a month and day for the accumulator reset. I will enter 1 and 1. I'll click Next and change the measurement interval. For this test program, I will use 10 seconds or longer to allow time for typing terminal commands. Since this is a test program to configure the sensor addresses, I will not add data tables yet. I will click Finish at this point. I like to put test in the name of the program to avoid confusion with the normal operating program for the station. Now I will send the test program to the data logger. I will need the wiring diagram created by shortcut for the next step. It is best practice to ensure the data logger is powered off before connecting sensors. This avoids voltage spikes that could damage the sensor. I will move the switch on the PS200 to the off position. The terminal bus kit uses spring terminals that firmly grasp wires. Insert a small flat blade screwdriver into the rectangular opening next to a round wire receptacle in the group labeled G. There is resistance when the screwdriver reaches the spring. Pushing the screwdriver further will move the spring, and the screwdriver will insert a few more millimeters. Put one end of the wire into the adjacent round hole. Ensure only the bare wire is clamped, not the insulation around the wire. Then pull out the screwdriver while holding the black wire in place. Give the black wire a light tug to ensure the spring is holding it in place. Connect the other end of the black wire to a G terminal on the CR1000XE. I will repeat with connecting the red wire between 12 volts on the CR1000XE and the 12-volt group on the bus kit. The white wire goes between signal on the bus kit and the C port on the data logger. In this case, shortcut chose C1. I will now begin connecting sensors to the terminal bus kit. I'll leave the SDI-12 signal wires disconnected for now. I will connect them one at a time when I'm changing the sensor addresses. Referring to the wiring diagram created by shortcut, I'll connect the ground wires first for each sensor. Next, I will connect the 12-volt wires. It is important to check the wiring diagram before connecting the wires of each sensor, because wire colors may differ between sensors. I may now connect 12-volt power to the CR1000XE and send my test program to the data logger. Now that my test program is running, I will use terminal mode to configure the SDI-12 addresses of the sensors. I will set the address on the HygroVue 10 first. Connect the signal wire of the HygroVue 10 to the SDI-12 group on the terminal bus. I will use the Terminal and Device Configuration utility to access the SDI-12 terminal. The Connect Screen terminal emulator can also be used. Press Enter once or twice to get a terminal prompt. Type SDI-12 to enter SDI-12 mode. I'm given the choice of which C port to access. I am connected to C1, so I type 1 and press Enter. I will first use the question mark command to check the current address of the sensor. If there is no response, I'll check the wire connection and 12-volt power. In this case, the sensor is expected to respond with 0, the default address. Next, I will send 0 I! to do the verify command. Note that the SDI-12 commands begin with the address of the sensor, in this case 0, and end with an exclamation mark. The verify command returns the sensor model and confirms I'm talking to the correct sensor. If I receive an SDI-12 busy error, I will try the command again. The busy error can occur because the measurement scan takes priority over manual terminal commands. A longer scan interval will decrease the likelihood of getting a busy error. Next, I will change the address of the sensor to 1 by sending the 0 A! command. In this command, 0 is the current address and 1 is the desired new address. The sensor will respond with the new address. Now that the sensor address in the running program matches the sensor address, I will switch over to the Data Monitor tab to confirm the sensor is working correctly. Waiting for my scan interval, I see valid measurements for temperature and relative humidity, confirming the sensor is working correctly. I'll now repeat the process to send the addresses in the BaroVue 10 and the RainVue 20. I will connect the signal wire of the BaroVue 10, then return to the Terminal tab in the Device Configuration utility. SDI-12 mode will time out if not being used, so I must re-enter SDI-12 mode again. Because there are two sensors connected to the same channel, I cannot use the address query command, so instead I will use the identify command, 0 I! to verify I am communicating with the desired sensor. This works because the address of the BaroVue is still 0 and the address of the HygroVue is 1. Now that I have verified I am communicating with the correct sensor, I will send the address change command to change the address of the BaroVue from 0 to 2. I will check measurements after I change the BaroVue 10 address. My 3 BaroVue 10 measurements are still showing NAN. That's okay in this case. When I set up my program in Shortcut, I accepted the default settings for the BaroVue 10, and it only records a measurement once per hour, and it hasn't been an hour yet. Instead of waiting for an hour to verify the sensor is working, I'll go back to the terminal and take a measurement here in the terminal to verify the sensor is reading. I get a return value, so I know my sensor is working. I'll connect the RainVue 20 signal wire and will use the identify command as before. Now I will send the address change command. If any command fails, disconnect the other signal wires and use the address query command to check the sensor address. Now I'll jump back to Data Monitor. The NAN readings are now replaced with valid measurements from the HygroVue and RainVue sensors. The BaroVue 10 is still waiting to reach the 1-hour measurement time, so it will remain NAN until that first measurement is recorded. I will go back to Shortcut and edit the test program to a final operating program for field deployment. I'll set my desired scan rate and add data tables for storing measurements. With the sensor addresses configured and the deployment program loaded, my SDI-12 sensors are ready for field deployment. For more information on SDI-12 programming or the equipment used in this video, visit CampbellSci.com.